All right, you are officially online.
We're live?
They're going to hear how loud you are.
Nice.
All right, this is one of those lectures every once in a while that mom and dad don't know how to help you with, and so they need to maybe see it. So that's why I will be. This is where we left off yesterday. So, we realized that in science, significant digits tell us a lot about the measurement. We started our idea and kind of lectures on this, and I said to focus on the zeros because we remember that numbers aren't numbers in science. Numbers are what?
Nothing. No, meanings.
Numbers are measurements. So they're not just numbers. So I warned you. Very sweet.
Yeah. Yay.
So, being measurements, we learned that final digit is actually an estimated digit. Whether it's you reading a graduated cylinder or it's the balance, digital balance, jumping and doing an algorithm and guessing the last number. That last number has an equal probability of being higher or lower. So, if we focus on the zeros, the first rule is very easy. If it's not zero, the only way it can not be a zero is if it's what?
Not a
Yeah, if it's part of the measurement. In other words, it has to register something in order to be something and not nothing.
Yeah, that makes sense.
Got it? So, if the number is not a zero, it's automatically part of the measurement. If it's part of the measurement, we call it a significant figure. Got it? Now, you got to remember, and this was the note we've landed on, that there are actually numbers. There are numbers that are part of many measurements that aren't actually part of the measurement. Huh?
You know what?
That didn't make
If
any
there's
sense.
If there's another actual number in between them, because like on 100 is still a number.
Well, 100 could be a number.
0.01. Still a number.
100 could also be a number with a lot less significant digits, and we're going to see the difference here in a second. A placeholding zero and leading zeros are not significant, and this should have been the note we landed on. They are vital. Notice that's capitalized. Like you can't just omit them. I'll show you in a second. They are vital, but what they do is they tell scientists where a measurement ends or begins. And so I will now show you what that means. For instance, according to this rule, at least the rules, let's use it a little darker. At least the rules I've written up here thus far. If I write this number down, if I write that number down, according to the two rules we have here, there's only one significant digit here. This zero and this zero are what called placeholding zeros. They tell you where the measurement actually ends. In other words, 100, written this way, say this is 100 grams. 100 grams written this way tells you that this was estimated as 100.
Oh.
Now, just because it has one significant digit, you can't just go like this and say, okay, well, those aren't important. Well, that's a lot different number. That's actually just what? That's one.
One space-based gram.
Yeah, so in other words, you can't get rid of placeholding zeros, and you can't get rid of leading zeros. Here's a leading zero. So according to the rules that we have right now, these don't tell us where the measurement actually is. It just tells us where it finally begins. They're vital. You need these 3 zeros to tell us that it begins in the 10,000 spot. But they are not counted as significant digits. Why? Because they're technically not part of the measurement. The measurement actually starts right here. Now, again, they're vital. You can't just get rid of them. But when you're asked questions like how many significant digits are in the following measurements, you will have to make sure you understand that that's how you deal with placeholding and leading zeros. Now, there are definitely other types of zeros. Those are the 2 examples I just gave you. Same type of thing I just gave you, so no big deal there. A 0, that is the final number after a decimal point, is always significant. A 0, that is the final number after a decimal point, is always significant. Now, after you've written that note down, I want you to just, for 1 second, just think, and somebody in this room is going to tell me why.
I have.
You have a guess or no? A 0, that is the final number after a decimal point, is always significant. All right, can anybody maybe ponder why? And you actually do have enough knowledge to answer this. It is not a placeholder. A placeholder would be not a significant digit.
Can you write a number?
Bennett. It's because of how the metric system, when we're taking measurements, when you add a 0 to it, it moves it up to the next level of measurements. So say you have a millimeters and you have 10 millimeters, then it moves it up to a centimeter.
I get what you're saying, but that is not the reason. It's a good guess. Yes, Rhett.
Does it just finish it so it's like not, it doesn't mean any, like it doesn't keep going? Like the decimal just stops?
You're getting close.
Yes.
Last guess. Go for it.
So, a 0 that is the final number after the decimal point. Does that mean, show me what that looks like? Okay, because that tells you how precise the measurement is. Right?
I can't say no to that, but that's not the reason. Yes?
Is it like the percentage of?
No. We've got to remember the last digit in any measurement is what?
Oh, okay.
It is the estimated digit. It is part of the measurement. In other words, you read this right on the line, or the machine read it exactly at 0. Therefore, it is the estimated digit. It does have an equal probability of being higher or lower, but it is the estimated digit. So in this case, and now we're going to start seeing something. It is the estimated digit. So if I were to ask you how many significant digits are in this number written as this, we'll assume they're measurements, you would say how many?
2,
Incorrect.
3.
It would be 3. Of course, those 2 are, because they're not zeros. That's a final 0 after a decimal point, significant digit. All 3. How about this one?
There's 2.
It is 2. These are leading zeros. They're not the final 0 after a decimal point. This one, of course, has got to be significant. And that is a final 0 after the decimal point. Now, what I want to show you is the difference. Believe it or not, some people before today might think that's the same measurement because it's not even close. Huh? So a scientist knows the difference between these 2 numbers. All right? One of these is a very precise number. The other one is a really not precise number. In other words, this scale, whatever scale you were using, all right, this actually can be anywhere from 149 grams to 50 grams. Both of those will round to that digit, to that place, to the hundredths, will all round to the to 100. So in other words, if you use this scale anywhere within these 99 grams, it would spit out that answer every time. If it was 78 grams, it would spit out 100. If it was 65 grams, it'd spit out 100. If it was 133 grams, it'd spit out 100. If it was 145 grams, spit out 100. Because that's the precision of that scale. It can only read to the 100 spot. Whereas this guy, that is a lot more precise scale. So it's estimating this digit. So this is anywhere from, 99.5. That would round up to 100.0 to 100.4. In other words, which one of these is going to give you a measurement that is actually closer to 100 grams? Now, they both can give you one that's 100 grams, but this scale is one you want to use in science. If you need 100 grams of sodium, you want to use this scale, because that one could lead to some major error. And it's all how the number's written. So we're starting to see why these actually matter in a science lab. We're starting to see why. Those two are vastly different numbers, even though when you look at them, before you entered this classroom this morning, they're like, oh, those are the same number. Well, no, they're really not. Nope, they're really not. And then your final one, where are we? There we are. Come on. Any zero that falls between two significant digits is a significant digit. It has to be part of the measurement. So now, you can answer this question. How many significant digits are in that measurement?
2.
No!
4.
It is all 4. The 1 has to be a significant digit. That's a final zero after the decimal point. Any zero that falls between two significant digits is now a significant digit. It has to be part of the measurement. So this one has all 4 of these as significant digits. All right. So why does it matter? Well, I kind of showed you why it mattered when it actually tells you the precision of the instrument. And here's another reason it matters, because now you can actually answer these questions right on your test and quiz. Because I'm going to give you questions just like this.
Right now? Right now? Got it.
Wait, yeah, this is good.
Yeah, no, it's kind of that's so bad.
Is it another thing
Study
for us
hall.
to sign to show that we really read the
Thursday. I'm in charge of the class.
No, we were just saying, we were on Thursday.
They want to do something.
Is this like a quiz?
No, it's not a quiz. We're going to do some examples.
Pass me the paper.
I would have it.
Yeah, pass it back. Those are yours too.
Here, 3.
2 weeks. That is not. It's not a good time either. All right, everyone should have a copy or getting a copy of the what we call worksheet, but they're just examples. We're gonna knock them out. I'm gonna look at the first column, just column 1, because we can't do the other ones yet. All right, we have all our rules. Here's a couple examples. How many significant digits in 709?
709.
3.
It is all 3, because this 0 falls between two significant digits. How about this one? 0.0509.
4.
We got a 4, we got a 5,
3.
we got a 3. Somebody's right, somebody's wrong.
3.
Placeholding 0, leading 0. Of course it's a significant digit. In between 2, the answer should be 3. So now we look at our worksheet. The first ones can't get much easier than that. How many significant digits are in the following numbers as they're written? Remember, these are measured values. Notice it says measured values. Now, they didn't put a unit down, but they could be grams, gallons, doesn't matter. They're measured values. So looking at the first one, how many significant digits? Yeah, it's all 5. They're all non-zero numbers. Doesn't get much easier than that. But I'm going across the top. Now, the next one does have some zeros in it. How many significant figures are in that measurement?
6.
I'm going across the top.
Oh.
I'm a
Oh, that one, 4.
4, 2. I got a 4 and a 2. What are we going to come down on?
4.
4.
Those zeros fall between 2 significant digits, so all 4 of those are significant. All right, what about 700,000? The way it's written right there.
1.
That only has 1 significant digit. The rest of those are called placeholding zeros. All right, we're going to go through the second column, and then we can put this sheet aside. How many significant digits in the first number?
6.
Yep, all 6 of those are. How many in the second number?
3.
3, 2, 3, 3, 3, 2, 3, 3, 2.
3.
It is-
It's 3.
It is 3. The first 3 zeros are leading and placeholding zeros. That final 0 is the final number after a decimal point. It is part of the measurement. Therefore, it should have been 3. And last but not least, 6. All right, you can put that worksheet off to the side because now we have to learn how to do these calculations. Here's the problem with... We did a bunch of examples, don't need to do those. Here's the problem with calculations, especially in science. We often put measurements together. And when you put measurements together, you actually are compounding error. And so what you need to do is make sure you don't pretend there's precision in an instrument that actually doesn't exist. And so that's why you always go with the least precise measurement. And so when adding and subtracting, you're going to focus on the decimal places. When multiplying and dividing, you're going to focus on the total number of significant figures. So, multiplying and dividing. The measurement with the least amount of significant digits dictates the amount of digits that are allowed in your answer. It is a simple rule, but it can make life hard sometimes. And I'll show you how and why. It's not a hard rule, but it does sometimes make life very difficult. So we can do is there an example here? No. So let's go back. Let's do a couple examples. Again, I'm going to assume these are all measurements. So 402 times 21. Well, it's obviously multiplication. So what we have to do is now count up the significant digits, and the one that has the least amount, we're going to go ahead and use that as the how many can be put in your answer. All right? And this should show you some of the issues with sometimes what we do to report answers. So 402 times 21. 402 has how many significant digits?
3.
And 21 has how many significant digits? So when we do this, we're just calculating. So we don't change how you do math. 402 times 21. Done. We get, this is what our calculator spits out. 8,442. Now, that of course, following rules of significant digits, is wrong. And 84 is also wrong. Now, that's closer to right because it has two significant digits. He's got that. But you have to report this number with two significant digits.
Do you round?
We can round to the nearest what, though?
100.
Yeah, we want to round to the nearest 100. 8,400.
I don't know. This is not real math.
No, it is not. See, if we're doing math, you'd be in math class.
Obviously, this is some like logical reason for this, but what the heck? There's no logic.
Shh, the logical reason is it's very simple. You can't assume precision where precision doesn't exist. These are measurements, they're not just numbers. So when doing calculations for significant figures, this is the rule for multiplication and division. In other words, 8,442, its best way to report this with two significant digits is 8,400. The four will not round to 8,500. Yes.
So if it was 402.0 and 21.00, it would then be 84.42?
So we want to,
If both those
we're
numbers
going
had
to redo this number. So would be what? 4.02?
402.0.
So 40.2.
No, like 402.0. So there'd be another significant.
402.0
Yeah.
and
21.00.
21.00. Now they both have 4 digits,
Yeah.
and now you could just do 8,442.
Okay.
Yes.
I was just wondering if that would. Okay.
Now, this is not going to be difficult. There are a couple things you have to remember. Order of operations and how to round. So for the most part, at least for what we've learned today, I'm feeling, I wouldn't say 100% confident, but I'm feeling pretty confident that if I give you a number like this, 302.0, you can tell me how many significant digits there are.
4.
There are 4. That 0 is between two significant digits. That's a final, so they're all 4. Okay, so I'm feeling decent about that right now. But now if I have to multiply this by 0.003, how many significant digits is that?
1.
That is only 1, which means my answer can only be reported with 1 significant digit. So now the question is, can I round properly and make sure I'm reporting these properly? So now I have to take 302 and I have to multiply by 0.003
You can like divide it or something.
and I get this answer on my calculator. How do I report that answer with 1 significant digit?
You just get rid of the 9.
Get rid of the 9.
Yeah.
Get rid of the 6.
Heck, get rid of it all.
Grind it,
Well,
burn it,
just
burn
point
it.
nine.
Kill
Yeah,
everyone.
round to 900.
Just
0.9.
0.9.
Dang it.
I knew it.
I did say just the 9.
So again, I understand that you guys can tell me how many sig digs. That's good. That's showing you got that concept down. Now trying to report the number. Am I rounding properly? How do I do it? Oh, that's going to be fun. That's why we're going to practice. And practice.
How do you know how many significant digits you're supposed to round to?
It would be how many is the least, and that one it was 1.
Okay.
That's a good question. Bennett just asked. Shh. Bennett just asked, how many do I know to round to? And for multiplication and division, you have to look at the one that has the least amount of significant digits.
Is it
Yes. All right, moving on. We do add and subtract too. Not as much, so that's good, but we do end up doing it. And here the number of decimal places in your least precise measurement are the number of decimal places allowed in your answer. So really now your focus is completely on the other side of the decimal places. And we know that that's important because we understand that that adds precision to your measurement. We saw the difference between a number written 100 and 100.0. 0. Although value-wise they are the same, measurement-wise they are not even close to the same.
Hey, look, sub. Just like you should sub to this channel.
Sub.
We're still streaming.
No, I can't live stream yet, so this is going to be video recorded, then uploaded.
Don't even edit it.
Please keep it.
I might cut out some stuff like me passing out papers and doing examples because no
You
one,
need to not cut out you talking about cutting it
and I might cut out me talking about cutting it
out.
out.
Don't do that. Hello.
Look, believe it or not, I don't have a whole lot of time, so I'll do the least amount of editing as possible.
Yeah.
You need to stream on Twitch. You get the most random people in here.
Yeah,
You can get donations.
people just all of a sudden just start coming. Hey,
It happens.
I'm not gonna watch this video game guy. I'm gonna watch Compass Chemistry.
You never know. Snap might
Cut this out, right?
All right, let's see. Oh, and I do want to talk about scientific notation here.
I remember that.
Yeah.
Gosh dang, I hate that.
Easy.
Oh, yeah.
It depends on what way you move that decimal place and to what you're going to be doing with the exponent on 10.
Go ahead, Dave.
I'm keeping it very simple. If you move the decimal place to the right, you're going to need a negative exponent every time you've moved that decimal place. If you move the decimal place to the left, you're going to need a positive exponent on 10 every time you do it. The reason I'm showing you scientific notation here is because you might end up to situations like this. All right? You get an answer. Like 100 in your calculator,
No, not 100.
and it says you need to report this with 2 significant digits. Well, how do you report 100 with 2 significant digits?
At least 2 or exactly 2?
2 significant digits.
Add 2.0.
Point
Maybe.
0.
Well, if I put 0.0,
Then it becomes 4.
that becomes 4 significant digits.
Mm.
And so, again, the reason we have scientific notation here is you will occasionally, it's very rare, but every once in a while you run into a number that you absolutely have to use scientific notation to tell the reader it's 2 significant digits. How do I do that? Well, I'm moving this decimal place, it belongs here, 1, 2 times, I moved it to the left, so I can report this number now. And I moved it 2 times, so I use a positive 2 exponent. Now notice what I've done with this number. I've made that a final 0 after a decimal point. I've told the reader that this has 2 significant digits. Again, it's only going to be in very rare instances, but every once in a while you'll run up to a number on a test or something. You'll be like, I know this has to be in 1 significant digit. How do I put it in 1 significant digit? Well, you often have to use scientific notation because that number and that number are the same number. And I have had students in the past just answer everything in scientific notation with the right amount of significant digits. And I don't care because when I see these 2 numbers, I don't see them any differently. I just don't. They're both 100 and I don't care whether you use scientific notation or not. It usually doesn't happen on the first test, but after they get it wrong, they keep getting it. By the way, you have to use significant figures the entire year.
Hooray. So yeah,
But did we use the microscope the entire year?
Yeah.
Good point.
That's true.
I can't tell you how many times you're going to be doing calculations in this class. And we did use the microscope
We used it.
multiple times. Once in the beginning,
Was it worth?
once in the end.
Was it worth the quiz at the beginning?
Yes.
Yeah.
I
No, he hated it, but
printed worksheet
He was so mad he
pages.
didn't get his 100.
Oh no, the
Oh my God.
No! Give it to us right now. Give it to us right
I
now.
don't remember anything.
It wasn't worth it.
All right. So, I didn't give you an example. I didn't give you an example of a addition and subtraction, but we do have examples of addition and subtraction right here on our page. So, let's look very carefully at the section number 2. And as we do this, again, please understand, we're not changing how you do math. We're just changing how you report these measurements. All right, so me like you using my FX300 ES, well, in this case, I'm using my cell phone. 32.567 plus 135.0 plus 1.4567 equals, and the answer is 169.0237, correct?
Yes. What? I got that.
I just pulled my
Yeah.
calculator out.
Where are we? Guys,
So,
what are we doing?
according to the rules for addition and subtraction, how many decimal places can I report in this answer?
What was that?
7.
Just one, right?
4, 1, 5. Again, addition and subtraction, we're just focusing on the decimal places, and you have to go to the one with the least precise measurement. So the answer is 1 decimal place. Very good. Why is that? Because the second measurement only has 1 decimal place. The rest of them have 3 and 4. So, how will I report this answer?
I have no idea. I don't.
Wait, can you repeat the
Let's
number
go
again?
1.07.
Oh, what number? Get a calculator out and put it in.
It's in my backpack.
7.
Here.
8, 9.
1.7.
Shh. What is the answer going to be?
169.0.
Since you're only allowed 1 decimal place, you just round to that 0.
That's right.
Zero.
That's 1 decimal place. You're only allowed 1 decimal place.
Answer then?
169.0.
169.0. All right, everyone in this classroom at this time is going to be silent. And you're going to do the second calculation. You're going to write down your best answer for it. And then I'm going to give you the answer for it in 1 minute. It doesn't take that long to plug 3 numbers into a calculator. You better round properly if you need to round. This one is definitely going to need to be rounded because it has multiple digits after, and you're only had to use how many?
I think I actually got it right.
All right, the answer
No.
written on your page should be 582.8.
Why?
Shh, good.
It should be 3 digits.
Oh, wait, it's not the same as multiplication.
Remember, on addition and subtraction, that's what we're doing here. You look at the number of decimal places, the number with the least amount of decimal places is the amount of decimal places allowed in your
Messed
answer.
up.
That's 3 digits.
That's so wrong.
No, there's one of them and it only has 1 decimal place. Decimal places with addition and subtraction.
You get it?
He said,
You can do that, actually.
98 has the least decimal places.
All right,
But 98 doesn't look decimal places.
98.
What is 9? What?
98.3 has 1 decimal place
Exactly. So that should be the number
of decimal places allowed in your answer
So it's only the decimal places that are remotely important.
for addition and subtraction. All right, now, last thing before I let you loose on your homework assignments or at-home assignments. All right, I'm going to go all the way down to K. Now, this does not happen often, but
Hey guys, it's not that hard.
in K, you actually have to do your order of operations. So, in other words,
What?
what is order of operations? So what do we do first? Yeah, we have to do these parentheses first. Now, please notice that in parentheses, there are addition and subtraction. Then, we're going to have to make sure we do our numerator, because there's multiplication up top. And then, we have to divide by our denominator on the bottom. So, I'm going to give you the next, I don't know, we'll go with 2 minutes on this one. Make sure we report, listen, follow your rules and report them properly first.
Did you know 1 in 10 people will drive drunk eventually?
Stop.
That was crazy fact. I mean,
It depends on whether you do addition. Addition, you were
I did addition instead of subtraction.
Sure. All right, in exactly 37 seconds, I'm going to complete this one on the television screen. Let's first of all see if there's any cheering going on. All right. Following your rules for significant digits and your rules for order of operations, your answer should have been. Yeah, you're right.
Oh my God.
All right.
I did 153. Where did that come from?
Now, here, listen up. Listen. Follow through so that we can make sure, again, getting it right on your first try could have been one of two things. I got it or luck. Now, here is exactly how you would do this work. So, for the first parentheses, that is an addition, and that addition should have come out to 28. .56, but we're only allowed to use one decimal place. All right, going to the second parentheses. that answer should have been 61.25. Why? Because I can only use 2 decimal places. And then last but not least, on the bottom, this is subtraction. Your answer should have been,
11.
should have been 11.000.
But it just gave me a 10.
Well, you have to have 3 decimal places. Why? Because the minimum amount of decimal places in that subtraction is 3. And here's why that's important. Because if you reported this as 11 and not 11.00,
Math is not math.
you would have reported this as 160.
Because it's not math.
This makes sense.
So that's why you need this in order to use 3 significant digits.
What
Multiplication,
happens if you get 153?
that means you plug something wrong into your calculator.
Oh, that makes sense.
Because those,
Easy.
none of these numbers don't.
I also learned that the thing does the PEMDAS for you.
He said it first.
Does the what?
It does order of operations for you.
Yes, if you put it in exactly how.
But I didn't know how many sig figs to include in my final answer, so I had to redo all of it.
Yes, I would redo them, especially if there's parentheses.
Wait, quick question. What did the top number come to?
I didn't do that. It wouldn't, because when you do multiplication and division, order of operations kind of says you just do.
Okay.
Yeah, there's not one does not trump the other.
Even with the 11.000, I still get 160, so I'm doing something wrong somewhere.
I'll have to look what you plugged in your calculator.
Well, I have all the starting numbers right, and when I times it, I have to have 3 significant.
Are we fighting?